Integrating artificial intelligence into urban planning with Autodesk Forma. If you have ever been on the internet in the past couple of years, chances are you may have heard about artificial intelligence. This sudden craze in artificial intelligence, or AI, is significant because the technology can potentially have a great impact on our lives and society at large. Nonetheless, you may have also read or seen on the news about the negative implications of artificial intelligence, such as job layoffs, deepfakes, or even scams. However, artificial intelligence can revolutionize our existing methods and improve our productivity and efficiency. It can help further our understanding of science, help our economy grow, and improve health and medical procedures. And in the case of urban planning and design, of which this video is about, there are many applications of artificial intelligence. Planning firms and teams are increasingly using artificial intelligence in their planning process. We can see many applications of artificial intelligence in projects all around the world. Now, if you are an urban planner, a designer, an architect, a developer, or are working in a field where integrating artificial intelligence would be highly beneficial, then it is about time to learn about AI and how it can make your profession and society better. So what is artificial intelligence? Artificial intelligence, in its essence, is an advanced technological system that incorporates computer science to emulate human intelligence. Artificial intelligence can be utilized to complete tasks and procedures that typically involve human action and/or intervention. It is all about learning from existing data, recognizing patterns and sequences, and making decisions based on knowledge. The reason why artificial intelligence is seeing widespread emergence into society is because the technology is great at mimicking human cognitive functions. So at its core, artificial intelligence is an agent of change because it can solve problems more efficiently, or at least complete the lesser tasks and procedures from their larger projects and objectives. Some of the skills that artificial intelligence can do are complex data analysis, such as consolidating expensive real estate market data, machine learning, where computer programs use algorithms and statistical methods to learn and make predictive decisions, and content generation, such as emulating human-like text and conversations seen in the well-known OpenAI program ChatGPT. In the field of urban planning, artificial intelligence can prove to be a very useful tool. For urban planning, there are varying intensity levels of applying artificial intelligence technology. This level of artificial intelligence use can range from traditional planning, where there is no integration of artificial intelligence technology in the planning process, to fully autonomized machine learning and decision-making algorithms that do not require the planner in the process. Now, let's look at these varying roles that both artificial intelligence and planners have in AI-enabled urban and regional planning. Traditional planning. In traditional planning, there is no use of artificial intelligence, which up until the modern era has been the primary method of urban planning. The planner is 100% responsible for planning decisions that come from identifying planning problems and collecting data. AI-assisted planning. In AI-assisted planning, artificial intelligence can collect data, process information, and generate plans. In this level of artificial intelligence used for urban planning, its capabilities are analyzing large amounts of urban data, which includes land use patterns, demographics, and transportation flows. Additionally, AI generation of maps and plans can help planners visualize and analyze urban conditions. Nonetheless, the planner is mainly in charge here. With the help of artificial intelligence completing time-consuming tasks such as data collection, the planner can make a more effective decision in a more efficient manner. AI augmented planning. In AI augmented planning, artificial intelligence technology can be used to identify data that is difficult to collect or analyze. It also may uncover hidden patterns from large data sets, simulate stakeholder behaviors, predict impacts of planning options, and evaluate plans. Furthermore, this degree of artificial intelligence technology can also provide feedback and suggestions to improve plans. With appropriate use of AI augmented planning, the planner can delegate lesser tasks to artificial intelligence, which could also potentially optimize methods better than human abilities. The planner, however, is still tasked with establishing planning goals and objectives, engaging with stakeholders, and proposing plans. With the integration of artificial intelligence, the planner can better make final decisions. AI automated planning. In AI automated planning, artificial intelligence demonstrates strong machine learning and automation capabilities to effectively automate the planning process. Here, artificial intelligence technology can identify urban problems, propose planning scenarios and solutions, and simulate and evaluate new planning policies. And to add to that, artificial intelligence can self-learn from other scenarios and become more intelligent over time. As it learns, artificial intelligence can better handle uncertainties, provide viable solutions, and mitigate potential risks in the planning process. The planner in this level of artificial intelligence usage is essentially left to delegate and supervise planning tasks and procedures. Nonetheless, a planner can help AI systems learn by defining planning problems and proposing objectives. Overall, the planner fulfills a supervisory role and monitors the outputs of the AI system. AI autonomized planning. In the final and highest intensity level of artificial intelligence usage is AI autonomized planning. To reach this phase, an AI system must be able to demonstrate a high level of intelligence and show its capabilities in achieving full automation in the planning process. As of now, there are no programs that can facilitate these demands, but a level of artificial intelligence that can reach and even surpass human abilities will be crucial in autonomizing the planning process while considering efficiency, equity, and domain knowledge of urban planning. Here, the planner is no longer, or at least very limited, involved in the planning process from beginning to end. The planner role essentially is not the role of a planner anymore at this level of artificial intelligence usage. Still, an individual knowledgeable of urban planning and sociology is necessary to make practical use of automation. This is because human intelligence can better address issues of empathy and ethical practices in urban planning. These include issues such as diversity, equity, and inclusion. Additionally, human capital is required for research and development into the creation of artificial intelligence technologies and programs. Now, let's use what we know and see how we can apply that into urban planning and design. Autodesk Forma, which is formerly known as SpaceMaker, is designed to assist planning and design teams in digitally delivering projects from the very first day. It integrates conceptual design capabilities, predictive analytics by machine learning, and automations to create solid and sustainable foundations for projects. The platform enhances efficiency through intuitive project setup and design automations, aiming to improve the workflow of planning, architecture, engineering, and construction projects. Oftentimes, planning design firms and teams may have several projects currently in their schedules. This creates a problem where there are several strict deadlines for multiple projects. Autodesk Forma successfully incorporates artificial intelligence to help planners, and even architects and engineers, to conceptualize initial urban design models quickly and efficiently. The main features of Autodesk Forma that utilize artificial intelligence in their functions are the model generational tool, which is called the Explore tool, the predictive analytical tools such as wind, solar, and shadow analysis, and the automations of the parking demand calculator and site design generator TestFit. Together, these artificial intelligence tools help planners, as well as any other professionals who can greatly benefit from a rapid form of conceptualization in their projects, and leads them to greater optimize their planning process. The following models are made completely by the Explore tool, and surprisingly, the artificial intelligence integrated in this tool helped generate several models in mere seconds. This reduces the effort and time required in creating conceptual designs to near zero, which is much more efficient than traditional methods. Once again, this integration of artificial intelligence can prove very useful for urban planners and designers. Autodesk Forma can be accessed by accessing the Autodesk website on your web browser. Autodesk Forma does require payment. However, you can start a free trial to begin your conceptual designs. Once you have an account with Autodesk Forma, you can access your Forma Hub. Here, we can see our project workspace. You can always start a new Autodesk Forma project by clicking the New Project button. Here, we can select any area where there is geographic data. Now, let's begin by looking at the Explore tool. The Explore tool can be found at the top of the tool ribbon. To begin, we need to set a boundary. We can do that by freeform drawing, creating a rectangle, a circle, or tracing an existing shape boundary. We'll start with a freeform shape. As we can see, the generative abilities of the Explore tool has created long, thin buildings and trees, all within our site boundary. But what if we're not satisfied with this model generation? Down below, the Explore tool provides several model generation suggestions. For instance, we can have a long, thin building, several buildings with roads in between, and more. Additionally, we can edit parameters within the Explore tool that can affect the generation of the model in various ways. On the right in the tool panel, we can scroll down and see the Explore section. Here we can edit the parameters that can affect the generation of our model. There are three main features in the model generation. We have buildings, trees, and roads. Additionally, we have other parameters: division width, building width, road width, number of floors, and tower block width. These five features affect the dimensions of our model. We can edit the parameters and see how it affects the model. Let's begin with division width. Let's say we want 60 feet for the division width. Now our buildings appear different. The Explore tool now demonstrates new model generations. From here, we can see more suggestions and select the ones we prefer. Another parameter that we can alter is the building width. Let's say we want thinner buildings. Now we see thinner buildings in the model generation. We can also change the number of floors that our buildings can have. Let's say instead of 4 floors, we select 2 floors. Now our model generations all have 2 floors in the building. Now, let's have a different boundary shape and size, and see what the Explore tool can generate this time. Once again, we go to the top of the tool ribbon and select the Explore tool. This time, we'll use the Rectangle tool to create our shape boundary. Just like before, the Explore tool generated several models of which we can choose. This time we have a little bit more variety. Again, we can change the parameters of our model to better fit our needs. On the tool panel, and scrolling down to the Explore section, we can find a subsection called Layouts. Here we can find linear buildings, city blocks, tower buildings, and mixed buildings. At this moment, all of them are selected. Let's see what happens when we deselect linear buildings. As we can see, it generated models without much linear buildings. Let's try it without city blocks. Now, the tool generated several model generations without city blocks. Now let's do tower buildings. And then we see several model generations without tower buildings. And then last, without mixed buildings. And then once again, the Explore tool generated several models without mixed buildings. You can use any combination of layouts to create a perfect design to your liking. Let's try without any other layouts besides tower buildings. Now let's try just city blocks. Additionally, we can change the dimension of trees in our models. Let's select a tree spacing of 20 feet. and a height of 25 feet. Now we see the Explore tool generate several models with trees that have changed based on the new parameters. As you can see, there's a large range of possibilities in which you can generate trees. Additionally, we can simply just select if we would like to have buildings, trees, or roads included into our model generation. Let's deselect roads for now. As we can see, the Explore tool generated several models without roads. However, we don't think this is practical, so we'll go ahead and re-include roads into the models. Now instead, let's deselect trees. Now our models have no trees. We can play around with all these parameters and adjust these dimensions to better fit our needs for our conceptual designs. Let's say we found a design that we enjoy. We can look around and see how it looks from a 3D perspective. We can zoom in and zoom out. We can also look at an aerial view. And we can take images. Let's move on by looking at the predictive analytical tools that Autodesk Forma provides. At the top of the tool panel, we can see several tools that we can use. For instance, we can do solar studies, We can run shadow studies, and we can do wind studies, among many more. Autodesk Forma uses these tools to run detailed analysis of our sites. For today, we'll just look at the wind analysis. In a simple wind analysis run automatically, we can see the varying degrees of wind. This is a comfort scale to check how wind affects the comfortability of people walking in the area. Additionally, the wind analysis tool can analyze wind direction within our site. We can run a detailed analysis and get better results. However, it does take several minutes to a few hours. The following project seen here is the result of a complete wind analysis. This was an already existing project that was made. The wind analysis took about 45 minutes to complete. As we can see, we can view a comfort scale of sitting, standing, strolling, walking, and uncomfortable. From this generated model in a different location, we can view what the analysis has resulted in. From the layout that was made and the trees, we can see that there's several sittings. We can see that there are several categories present. Sitting, standing, strolling, and walking, which is many of the roofs of the building. All of these suggest a level of comfortability for the population if they were to live in this hypothetical generation model. Additionally, we can adjust the wind direction. There's also several comfort skills that we can choose from. And we can view a percentage of the comfortability locations in our site. Additionally, we can view wind direction and how it moves through the site. We can choose several wind directions from the site and wind speeds as well. Darker blue and purple and up to pink suggests there's a high probability of wind speed reaching higher speeds in these locations than other areas within the site. Lighter areas show that the wind may be more still and suggests that it's more comfortable for residents. Again, we can see a percentage total of the level of wind that is present in the site area. And as before, we can see a 3D projection of the entire site. We can zoom in and we can zoom out. There's a great amount of flexibility within this site. We can simulate what wind speeds and wind direction can affect the site area. This shows that artificial intelligence can, with great speed and efficiency, create detailed plans and sites, as well as analysis. Now, in this presentation of images, we can see the variability between different wind directions. A north wind coming from the north shows the wind directions through the buildings. Lighter areas are in this location, and the areas with trees. Faster winds can be expected on the roofs. Now we can see an east wind. In an east wind, we can again see a light location here, in this location, and this one. The building locations, additionally, are expected to see high wind speeds. A south wind is opposite of a north wind. However, the speeds still are relatively the same. We see lighter areas more in the tree regions now, and some spots between buildings. Once more, the buildings are expected to see higher wind speeds. And finally, a west wind. A west wind shows that wind is slower in the same location up here, and also these locations. The region of trees in the middle has a slightly faster wind speed than the other wind directions. All of this helps us conclude that a wind analysis can be very beneficial when creating conceptual design plans. Now, let's see how we can incorporate artificial intelligence to create a site plan of a parking lot. We can begin by locating the extension. We must select Add Extension. Here we have several extensions. We scroll down and select the Test Fit extension and agree. Now we have our test-fitted parking extension included into Autodesk Forma. To use the tool, we must begin just like before when we do the Explore tool. We must start with a site boundary. We can use the Freeform tool, Rectangle, Circle, or trace an existing shape boundary. We'll use a rectangle. As we can see, there's a parking lot created in our shape boundary. As we can see, there's a parking lot created in our shape boundary. This is done automatically. Thank you for listening. Thank you for listening.